Alright, so the recording has begun. Alright, so let's dive into this math paper. Last time we were dealing with the question that we was trying to figure out what was the solution to it. And so I want to share with you how we are going to go about doing that question. Okay, so I need to find out. It certainly there was in this paper. What is this one? 20 years younger. Is this one? No, it wasn't this paper either. Okay, it's this paper. Okay, so we did the prime factorization. We did the Mrs. Davis and the exercise books. The last thing we was on was this one, and we did that as well. Okay, this is what we are going to be on. Okay, so nine boys. Let's write this down. So
Mr. Patek, we already did this question.
I'm saying I'm going to show you the reason why.
Okay.
The rationale. I don't think we didn't solve it fully. We definitely didn't solve it fully. So I'm going to show you the rationale behind this.
We're supposed to come back to it.
Yeah, we're supposed to come back to it, certainly. Okay, so it says, and it's a very neat idea, very neat idea. But it says 9 boys can paint a basketball court in 3 hours, right? How long should one boy take working at the same rate? Okay, so if we look at it, right? If we look at, so we have basically two things going on now, right? We have, sorry. All right, we have two things going on now. Let's look back at it. We have, we have time. So we have time. That's one unit or one quantity that we're dealing with. So we have time, and then we have number of boys. Okay, so we have time and number of boys. Okay, so time and number of boys. And I want you to think about something, right? If we increase, right? So if we increase the number of boys, right? So it says now these boys, they're working on painting this basketball court, and 9 of these boys can paint this court in 3 hours, right? 9 boys can paint the court in 3 hours. And so the idea is that if we were to increase the number of boys, right? If we were to increase the number of boys, so increase. If we were to increase the number of boys that are painting the court, what do you think is going to happen to the time?
It'll be less. It'll be a longer time.
It'll what?
It'll be less.
Would it take more time or less time? If we
Less time.
It'll take less time, right? So it'll take less time. Okay. So if we increase the number of boys, all right? If we increase the number of boys that are painting this basketball court, then the time taken would be less, right? So it would decrease, right? The time taken would decrease. And so what is the relationship, right? What is the relationship between time and the number of boys?
They're inversely proportional. Or decrease.
Right? So we say that time and the number of boys are inversely proportional to each other, right? They are inversely related. All right. So let's put this out. So note that Note that time and the number of boys are inversely related. That is to say, if we increase the number of boys painting the court, the time it takes to paint the court would decrease. So if we increase the number of boys, right, painting the court, then the time taken would decrease. And so they're inversely related, they're inversely proportional. So if you increase one, the other one would decrease. If you decrease one, the other one would decrease. All right. Now okay, so let me know when I can move this before I give you some more.
So you say if one decreased, the other one get decreased too?
No, if one increase, the other one decrease. If one decrease, the other one increase.
Mm.
Understand? Like opposite sides of a
That's
seesaw.
why you can say decrease and decrease the same.
No, that's my mistake. So if we increase the number of boys, the number of the time it takes would decrease. All right. So they are inversely related. So mathematically speaking, what does this mean?
If we decrease the number of boys, it'll take longer.
So we can represent this idea mathematically. So we can represent this idea mathematically by using the following formula, the following equation, where T is the time in hours, and we say B is the number of boys, and K is the constant of proportionality. All right, so we can represent this idea that we said, where we said that if we increase the number of boys, the time taken it would decrease. We could represent that using this formula, all right, using this equation, where T in the equation is number of hours or time in hours, B is the number of boys, and K is the constant of proportionality. Very good, Dior. Wow, you did this before class?
No, I do it just now. I just remember inverse and direct and stuff. It just hit me just now.
It just hit you. Okay. All right. Okay, good. So in this case, T is the time in hours. So T is going to be equal to K, capital K, This is going to be K divided by B. And so what this means is that, so this is the equation that we're going to be using. This is saying that, hey, these are inversely related. The T and the B is inversely related. All right, so in our case, what is T? So how much time does it take for the 9 boys to paint the basketball court? How much time does it take? Anyone? How much time does it take for? How much time does it take? Oh, 1 moment. Someone's in the class. That's not supposed to be here. All right. One moment. Someone is in the class who's supposed to be here?
Yep.
Who that is? Oh, okay. So let me remove him.
I've been telling you that for the past time.
Okay. All right, thank you.
What you mean by you supposed to do that?
All right. All right, so I'm sorry about that. Thank you for letting me know. You should have said, maybe next time just speak it. You don't have to.
I didn't want that person to tell me something I had to, you know?
Okay. Okay. Yeah, so this is the so T is going to be equal to the time in hours. All right, and the time in hours is how long does it take the guys? How long does it take the guys to
3 hours.
3 hours? Good. Good. So that means T is going to be equal to 3, and the number of boys is what?
9.
9, right? So number of boys is 9.
It's your T.
Yes, ma'am.
But you just putting on the side what it can be, or that's how you want us to write it on?
No, I put it on the side what these are. So it's just something on the side. So now we're gonna fill it in, right? So T is what?
3.
T is 3. Very good. And 3 equals, and then K is the constant of proportionality. We need to figure out what that is. And so we do not know what that is yet. So we need to figure out what that is. So we keep K, and it's going to be over B. B is the number of boys that we have, which is 9. All right, now to solve for K, what do we do? To solve for K.
We multiply.
We have to cross multiply to solve for K. So we're going to multiply 1 by K and 9 by
3.
3. So that means that K, which is the constant of proportionality, K is going to be equal to 9 times 3 or 3 times 9. Okay? So K is going to be equal to, what is 9 times 3?
27.
Say it again. What is 9 times 3?
27.
20.
27.
Very good. So that means that the constant of proportionality is 27. The reason why we need this constant of proportionality is because it's going to help us to figure out when we only have one boy, right? So we need to know what K is. Okay, so we know what K is. So now let's figure it out for one boy. So now we're trying to figure out if we only have one boy. If we only have one boy, what would the time be? If you only have one boy, what would the time be? Right? The time is, we don't know. But we do know that K is equal to what?
27.
27. Good. So remember this formula, that the time, or T, is going to be equal to K
K over
constant of proportionality over B, right? Now, how much boys do we have?
1.
We only have one boy, according to the question. How much is our constant of proportionality?
We don't know that.
We just figured out it's 27.
Oh, 27.
Yeah. And then, so T is going to be equal to 27 over 1, which is what?
27.
27. And so that means it's going to take 27 hours, right, for one boy to paint the basketball court. If it took 9 boys, 3 hours.
So we can't do it Kennedy way?
That's exactly Kennedy way. You multiply the 3 times the 9.
I mean, without doing all that K and B, you could just put 3 times.
You just could put 3 times 9 and equal to 27, yeah. But this is the math behind it.
Okay.
This is the reason.
Yes, Mr. T, could you go back so you can take a picture of the question?
Sure, no problem.
Yeah.
Mas petit there.
All right, Al.
Okay, so it's fast as we start.
Okay.
Can you go back to the notes, please?
The notes. What notes? What notes?
The one we just was on before that. The slide you was on before this one.
Yes?
Yeah, that's it. Yeah.
So all you need to do is take the number of boys multiplied by the number of hours and divide it basically by the amount of boys that they give you. So that's the easy way to think about it. So that's why, Kennedy suggested earlier when he was doing this, she said, Mr. Petit, all we need to do is take the 9 times the 3 and divide it by 1, and that will give us the answer. And that's true. That's absolutely true. But I just showed you how and why it works, right? So you don't have to do this formula every time if you don't want to. All you need to do is take the number of boys multiplied by the hours and divide it by how much boys they give us. Okay, again, take the 9 multiplied by the 3 and divide it by how much boys they give us. And so I give us 27 hours. Okay, so let me allow you to do the second one and to see how you would do it. So the second one says, hey, what'll happen if we have 5 boys? What will happen if we have 5 boys? And so how would we figure out if we have it for 5 boys? What are we gonna do?
We'll still use the 9 times 3 divided by 5.
Very good. So to figure out, so again, we do the same thing. We already know that, okay, like we said, you multiply the number of boys by the number of hours, and then you divide it by how much boys they give you. In this case, they only give us 1 boy, so we only could do 9 times 3, which is 27 over 1. But in this case, they give us 5 boys for this question. They give us 5 boys. And so in order to figure out the answer, what you do is you say 9 times 3, and you divide it by the amount of boys they give you. In this case, they gave us 5 boys. And so the number of hours it would take 5 boys working at the same rate equals 9 times 3, which is 27. So it's going to be insert so it's going to be 9 times 3 divided by 5. And we know that 9 times 3 is what? 27. And 27 divided by 5 is what?
5.2.
Is what? What is 13 points? What is 13? What is 27 divided by 5?
5.2.
Say it again. 5.2, not 5.2.
Five point four.
5.4. It's gonna be 5.4 hours. Okay. What if we wanted to know? What if we wanted to know? And the reason how we get 5.4 is we basically fill in the slots. We know that T is equal to K over B. K is the constant of proportionality, and K is 3 times 9, which is 27. And we just divide it by how much boys we have. In this case, we had 1 boy, so we divide it by 1. And then in the next case right here, we had 5 boys, so we divide it by 5. Now let me ask a question. What if we had 7 boys? How long would it take? If we had 7 boys, how long would it take?
2 hours and 30 minutes.
Say it again. We had 7 boys.
2 hours and 30 minutes.
No. What would we do if it was 7 boys? It would be
So you're 3.85.
yeah, 27 divided by 7, which is gonna be 3.85 something, right? But rounded to the nearest if we round it to 2 decimal places, it's gonna be 3.86 hours. If it was 8 boys, it would have been 27 divided by what?
We have 3.
8, which is what?
I might be question when I'm finished.
Yanabala. 3 point what? 75 hours. Okay, so that's how we do these stuff. Any questions?
Yeah.
Yes, sir.
Why you round it off?
I rounded off because we don't want to write all those numbers at the back, all right? And so it's an approximation of this. This is correct to 2 decimal places, all right? So I just didn't want to write all the numbers. And in general, if they give you something like this, they wouldn't give you something that would be so long. It was a made-up question that I make up, so that's why I had all the numbers at the back. The decimals that they give you usually is going to be finite decimals. If it's a finite decimal, then if it's an infinite decimal, then you would want to round it to at least 2 decimal places. Usually they'll tell you that too. Alright, Lenroy, you don't have to have your camera on. You can have it off. Lenroy, you don't have to have your camera on. Okay, good. Well, okay, so we good with this. I want you to send me the notes for me, please. The notes of what you did. Thank you for the notes already, Miss Dior. And
How we
Kennedy.
got 8? Oh, never mind.
Okay, Kennedy, sorry for that combat you had to do a few moments ago.
No, I used to it. I had like roasts ready. You see, I didn't even get it.
But remember we talked about a woman's role.
See, that's why I didn't want to mute. That's tell her something for real.
We talk about a woman's role. She is to win everything by love.
Sometimes
This
you
is
gotta
21st century.
get over that. Sometimes it's too deep.
Yes, we are very sorry about that. I don't know. I don't know. At least sometimes I don't know. Some people don't have no life, man. But at least he ain't as bad as the other ones. The other ones, they was talking.
It was moaning and thing.
It was, oh boy.
They was something else. All right. Okay, so let me know if I can move this. But I'm glad we got some clarity with this question, because and I'm glad that I was able to figure out with the math behind it, like why does it make sense? The reason why it makes sense because we do an inverse proportion, and so that was good to know. It also validated what Kennedy was saying. I just didn't know how to explain it in mathematical terms, and so being able to do it really does my heart good. I hope it does the same thing to your heart, like being able to see it mathematically spoken and explained really really is good. Okay, so oh wow, I really don't want to do this one. I don't want to do this. So we gotta do some simultaneous equations. Where's Nancy? I ain't Nancy these days.
I'm right here.
You right there? You sure? Keep it quiet. You're on the quiet side.
I'm eating dinner, sorry.
Oh, you're eating dinner, okay. And you want to offer Mr. Fleet now. I understand. I understand. I'll rate it.
Okay, I'll help you with this question.
Okay, good. Perfect. Okay, you redeemed yourself. Alright, so this one, there's two ways to do simultaneous equations. We can either, thank you so much for the notes that are sending in, and also if you are here, please place here present in the chat box. Is it just me, or it's like Wednesday just came so quickly, man?
Yeah, I really did.
Yeah, Wednesday just tomorrow's literally Thursday. Like tomorrow literally is Thursday. Wow. Anyway, solve the
Yesterday.
yeah. Solve the following pair of simultaneous equations. So this is a simultaneous equation. The reason why it's a simultaneous equation is because we are to solve the variables simultaneously, right? At the same time. That's what simultaneous means. We're solving them at the same time. Alright? Or together. Right? And so here, like I said, there are two ways to do simultaneous equation. We could either do substitution or we could do elimination. Now, you have to know which one is going to be easier, right? And this one is ripe for substitution. The reason why it's ripe for substitution is because usually if something was elimination, if something was elimination, it's going to be something like this. It's going to say, like you're going to have your x's and your y's line up together perfectly. So it's going to be something like this, equals to 0, and then say this is 7x minus 3y. Let me still use the plus, equals to 9. And so the major difference between this one and this one is that the x's are perfectly lined up together the y's are perfectly lined up together, and the constants are perfectly lined up together. When you see something like this, the first thing coming in your mind is elimination. You want to use elimination for this one. Because everything is lined up perfectly for you. That's screaming out elimination. Okay? So you want to use the elimination method for that one. Now, this one on the other hand, like, look at the x's and the y. Are they lined up perfectly?
No.
No, right? This is telling us, hey, you really don't want to do elimination, because if you're doing elimination for this, you'd have to arrange it back into order, and we really ain't want to do that. Okay, if you were trying to do elimination with this one, not that it could work, but you'll have to arrange things back into order, and we don't want to do that. Right? That's taking up time, and it cries out in the substitution, because we already have what y is explicitly. We know that y is 3 over 2x. That's what y is. And so what we need to do is put that right in here so that we can substitute it. So that's another reason why it's substitution. Number one, because the variables are not, organized, in order. And number two, because they tell us explicitly what y is. Like, we know directly what y is. Y is 3 over 2x. And since seeing that we know that already, all we need to do is put that into the second equation. All right? Okay, so that's the idea. So let's use substitution for this one. Notice that they didn't tell us which one to use. So we could use either one. So we are free to use either one. Now, if they tell you to use elimination, son, use elimination. If they tell you to use substitution, use substitution. But in a case where they don't tell you, well then, use the one that's most convenient. Alright? Okay, so let's go and let's do this. So the first thing that we're going to do is we're going to take this equation. So let's name the equations first. So we're going to name this one equation 1. And we're going to name this one equation 2. Alright? So if I would have write, I feel like I did this question with you all before. Nancy, did we do this question before? I feel like we did it before.
A similar questionnaire.
Similar question. I mean, with you all in the course. Remember that little mini course I did?
Yes, sir.
Yeah, I feel like we did. So the first step is, step 1. If you're writing notes, just wanna label your equations, right?
Could we just as soon as do it, we could just go and do it, right? We don't have to.
Yeah, go right ahead and tell me what your values are.
Okay.
So the first thing is you want to label the equations. Equation 1, Dior. Dior?
Yeah, so
You already finished this one, right? Or are you still working on it?
I'm still working on it. It's a lot of writing.
Okay, alright. Okay, good. So the first thing you want to do is, but let me know when you finish what your answer is. The first thing we're going to do is label the equations. So we label this one equation 1, label this one equation 2. The second step is you want to, so after you already label the equations, you want to substitute that's what's wrong. Let's use the word replace then. Replace equation 1.
Say
Do it again. Step 1 was label your equations. Okay? And
I can get a second, please.
Yeah, no problem. So you want to label the equations, and the next thing that you want to do is you want to substitute equation 1 with the value of y.
I got it.
Okay. Okay, so substitute the, substitute equation 1 into equation 2. And so what I mean by that is we're going to take this is equation 1 and we're going to place it into equation 2. So we're going to take this equation and put it directly into equation 2 by replacing the y. So this is going to be 3x plus 2. Are we going to put y? What are we going to put instead of y?
3 over 2.
3 over 2x, because they tell us that y is 3 over 2x. So since y is 3 over 2x, then just put it in. So it's gonna be 3 over 2x open bracket plus 4 equals 0. So that's the second step. Replace or substitute equation 1 into equation 2. Now the third step. After we already substitute that in, we want to solve for x. So the third step is that we want to.
Mr. Check all my answers.
Which answers? Okay. Solve.
You want to know them or?
Yeah, one more. Solve for the value of x. Good. So using our principles of algebra, so give me your answers that you got, Nancy.
Negative 2 over 3 is the x value and negative 1 is the y value.
So x is negative 2 over 3. And y is what?
Negative 1.
Negative 1. Dior, you got the same thing? Or you got something different?
I just sent it to you a couple minutes ago.
Okay. You got the same exact thing?
Yeah, so, and I checked it too.
And you checked it too.
Well, that's the answer.
Well, you say, well, that's the answer. Okay. Alright, so we have the math whizzes, right? Dior and Nancy. Very smart individuals. Okay. So next thing we're going to do is solve for x. So what we're going to do is we're going to cancel out the 2, right? These 2's. And so we are left with what? 3x
plus 3x.
Plus, we still left with the same 3x, right? 3x plus what? 4 equals 0. We could send this 4 over, right? That's going to be equal to, what is 3x plus 3x?
6x.
6x.
Very good. And when we send over the positive 4, it becomes what?
Negative 4.
Negative 4. And then we want to divide here both sides by 6.
6.
And so this becomes x is equal to negative 4 over 6. But if we simplify negative 4 over 6 by dividing both sides by 2, what do we get?
X is equal to negative 2 over 3.
Good. We get that x is equal to negative 4 divided by 2 is negative 2. And 6 divided by 2 is 3. So we have negative 2 over 3. So x equals to negative 2 over 3. Voila. So that's what x is. So we are able to solve for x. Any questions on this? Please let me know. Don't be shy.
No, sir.
Okay, so we know that x is equal to 2 or negative 2 over 3. What we did, we took y, we placed it into the second equation. After we did that, we solve for x by first what? Canceling out the 2's, all right? Then we are left with 3x and 3x, so it's going to be 3x plus 6x plus 4. We send over the 4 because we're trying to isolate x, make x by itself and everything else on the other side. Then we are left with 3x plus 3x, which is 6x. We divide both sides by 6, so we get x is equal to negative 4 over 6. We divide top and bottom by 2, giving us negative 2 over 3. Okay, so that's the thing. All right, now the final step is we're going to step number 4. We're going to solve for the value of y. Seeing that we already have the value of x, we're going to take the value of x and substitute it into our equation 1. So let me put this in blue so we wouldn't get mistaken. So we know that x is equal to negative 2 over 3. That's what x is equal to. So we got based on this that x is equal to 2 over 3. That's what we got. And so we're going to use equation 1 where it says that y is equal to 3 over 2x. And I must say using equation 1. So using equation 1. And so y is equal to 3 over 2 x. Remember what x is, right? X is simply what? Negative what?
2 over 3.
Good. My goodness. This is 3 over 2. X is negative 2 over 3. Negative 2 over 3. Close bracket. And so it's going to be, we cancel out the 2 and the 2, right? And then the 3 and the 3. So we left with y is equal to what? Well, 2 goes in itself once. It goes into 2 once. 3 goes in itself once and a 1. So 1 times negative 1.
You just do?
Like, okay, I cancel out all the ones that are in common. So 3 and 3 cancel out. And then 2 and the 2 cancel out each other. And so we are left with 1 times negative 1, which is negative 1. And a 1 times 1, which is 1. So y is equal to negative 1 divided by 1 is simply negative 1. And so that's all we got, negative 1. So x is equal to negative 2 over 3, and y is equal to negative 1.
If you cross them, why you just still like put the 1?
Because when we cross out, what we're really doing is dividing by a number. So when we cross out 3 with 3, we basically divide both of those numbers by 3. And so if you divide 3 by 3, it's 1. And if you divide 3 by 3, it's 1. If you divide 2 by 2, it's 1. And if you divide 2 by 2, it's 1. Remember, this is negative 2, so we still keep the negative. Understand that, Ms. Cooper?
Yes, sir.
Okay. Any questions on this?
It's pretty, I use equation 2 to get my answer, even though, because
I use equation 2.
I just didn't want to confuse myself with the fraction, so I just.
Oh, thought the fraction would have been harder. Okay, all right.
No, I didn't say that. I just didn't want to get lost again, so.
Okay. But equation 1 was the easiest one to use.
I know it was, but I just didn't want to confuse myself.
Alright, that's true.
But it's weird that how all two of them could add up to -1.
Yeah, all two of them should. That's the idea. Alright. But because equation 1 is just like we already know what y is. Y is equal to 3 over 2x. So I mean, literally all you need to do is put the x value. So yeah, I wouldn't use equation 2. That means I have to send. Wow, you really use equation 2. You have to send the 3x over, send the 4 over,
I
divide
didn't do
by
all
2.
that, though, Mr.
Wow.
Petit. I didn't do all that.
What do you do?
Okay. So I just put in, okay, you see where the where the x is, I just put -2 over 3 in the bracket, then I plus y, plus 2y plus 4 equals 0, right? And then automatically it would give me -2x, -2
Yeah.
plus y, 2y plus 4 equals 0.
Yeah.
And then I would just rearrange it. So now put 2y, and then I'm in bracket, I'll put -2 plus 4 equals 0.
Yes.
And then automatically I'll get 2y plus 2 equals 0.
Yes.
And then I minus 2 from both sides.
Yes.
And then I just get, and it on one side I leave with 2y equals -2.
Yeah.
Put it over 2 when I got 1. I got the shortcut way. I didn't do that.
That's still long though. That's still long. You know much and then. But that's genius though. I'm glad that you could handle yourself with the algebra. Once you could do that, that's fine. But don't be afraid of your fractions, sis.
So wasn't that, you see like how I did it in the, if you did this experience just now, like how you had the fraction there, to me, fractions in my calculator, get too technical, you know what I mean? So I was like, yeah, no.
Well, you could do 1.5 divided. Anyway, don't worry.
I didn't even think of that way, because I could have do that way too.
So, step 1 is label your equations. Someone asked me to go back. Step 1 is label your equations. Step 2 is substitute equation 1 into equation 2. Step 3 is solve for the value of x, and then step 4 is solve for the value of y. Alright, send me the photos for me, please. Let me see how we're looking for this. Thank you, Sean. Thank you, Dylan.
So, Mr. Petit, I could go back on silence, right? So you don't need me no more for the class.
No, man. Stay alert. Stay up.
Okay, I'll try.
Alright. Your dinner over, right? You ready to eat all your food and offer me? So, the least you could do is... Alright. Alright, so... Okay, so let's go. So, simultaneous equations. Nice. Okay, so... It's a good question for all of us. I can't wait till we get to this. Number 6. Very good question. Okay, so let's go back to the familiar questions. I'm really happy we got over number 4 though. Wow. Inverse proportion. Now let's see. Okay, nice. Easy questions, right? These questions we see from grade 5 and stuff. Express 90% as a decimal and express 90% as a fraction in lowest term. I'm gonna allow you all to do this because I was helping someone who was in grade 6, I think, with stuff like this. So, like, come on, this ain't deep. So, try this out. Express 90% as a decimal and 90% as a fraction in those terms.
The thing is, the thing I just learned, that's like, I mean, we do this in high school, like, and I write it, I do this, you know.
Uh-huh. So do it. Go ahead. Don't be shy. Express 90% as a decimal and then 90% as a fraction in those terms. Thirty more seconds. No one got an answer yet?
Yeah.
You got?
Going to one that PGC, the PGC will do I get to do it.
Okay.
Or you,
no problem.
I don't know if you want them to do it.
Yeah, give them an opportunity.
Okay.
Give them an opportunity. Thank you, Dior. Nancy, you need to get your phone back. At least you could message me the answers. Very good, Dior. Anyone else? Cooper, Kennedy, this is your territory.
0.09.
Not 0.09.
0.9.
Say it again.
0.9.
I can barely hear you, Cooper.
She said 0.9B.
Okay. What you got, Kennedy?
Same thing.
Same thing. What you got for the fraction?
9/10.
9/10. Who said that?
Ashnet.
Ashnet. Very good. 9/10. Ashnet. And so, this is how we do it. So, for a decimal, if we're trying to take 90 and express it as a decimal, what we do is, first we put 90 here. First we put it here, and then we know that the decimal point is always to the right of a number. So this is where the decimal point is. Now, because this is two zeros, this 0 and this 0, we have to move the decimal point 2 times to the left. So it's going to be 1 and 2. And so decimal point is going to be right here. And so we have to put a 0 in front of that. And so that means that equals to 0.90 or 0.9. So the answer here is 0.90. Now, they say they want a fraction.
9/10.
9/10. Very good. Who said that?
Lionel Finger.
Lionel. Very good. Alright, so what we do is, you see 90%. If we look carefully at 90%, right? 90%, you see these two zeros there. So you could basically, the first thing you do is you take the 90, when you make that your numerator. So the 90, the number in the front is always the numerator. And then the number, the percentage sign is basically to remind you that you're dealing with 100. So this bar you could think of as 1. And this 0, place it here. And then this 0, place it here. And so you basically have 90/100. But they want us to express it in simplest term. And so we have to simplify it, right? What could be simplified? What could we cancel?
I know both.
Say it again.
We'll cross out zeros.
You cross it a 0. So this 0 will go with that 0. And so we are left with what?
9/10.
9/10. And so that's our answer. 9/10. So if we had 80%, what would it be?
8 over 10.
8 over 10. For the decimal, what would it be?
0.80.
0.80 or 0.8. If we add 71%, what would it be? For the decimal?
0.71.
71. And then as a fraction, it would be what?
The same?
71 over
5 over 7. Wait, not 5 over 7.
71 over
100.
100. Now, can we simplify that?
No, sir.
It would remain. If we have 73 written as a 73%, write that as a decimal.
0.73.
0.73. Good. And as a fraction,
73 over 100.
73 over 100. Very good. And we can't bring that, further down because these two numbers are not reducible. Okay. But if you're dealing with a number that could, a fraction that could be simplify it. Okay. That's number 3. Okay, next up is this one. So it says here, I want to be up right after that one. See? Okay, so we have simple stuff afterwards. Let's do number 2 before we move on to. So the question says the following. So you have a bag, right? And apparently this bag is 40% off, right? So that's a big sale. 40% off. That's huge, man. 40% off. So after the sale, or I should say during the sale, which is 40% off, the price of the bag now is 115. Okay. And so if that's the case, if the current price now after the 40% off discount is 115.
Listen, Petite.
Yes, mom.
You're saying 40% off. That's saying $40 off.
Oh, $40, buddy. Oh my goodness, I thought it was 40%. Sorry. Sorry, I'm so sorry.
I thought I needed glasses at that moment.
Sorry. Oh, my apologies. It's $40 off. Okay, so it was $40 off. Now it's $115. So in a sale, the price of the bag is reduced by $40 to $115. What was the original price of the bag?
$95.
Say it again?
$75.
Oh mercy. Oh my goodness. Oh my goodness. I remember I am not your. If you go in the exam, tell them Mr. P is not your teacher, okay?
You gotta
Original price of the bag. How do we do this? Remember, they tell you that after they reduce the price by $40, it's now $115. So you can't take away the 40 again. You understand? So
I didn't.
So the original price, which you have to find the
Odd.
The odd, very good.
I was saying odd earlier.
All of a sudden.
I thought I was wrong, Mr. BT.
Yeah, you're right. So you have to add it. So it's gonna be 115 plus plus 40. That's gonna equal to what?
155.
And it makes sense because if we take away, right? If we take away 40 from 155, we get what?
115.
We get 115. Okay, so
Yeah.
the original price is going to be 155. So make sure to read the question carefully. Okay, Miss Cooper?
I said that. So,
What's the name?
Lenroy.
Enroy, okay. Lenroy, I haven't been seeing you these days.
It's just busy with school and stuff.
Busy at
So,
school, okay. So I could be seeing you more often?
yes, sir.
Alright, that's good. That's good. How do you know we had class today?
My dad told me.
Okay, you end up telling. Okay, good. Just use the same link. That's good. Alright. Tomorrow, same time. Alright, so let's move forward. Okay, so let's move on to this other question. I'm going to give you an opportunity to write it down. This one. Okay, so here we are talking with Jeremy. Sorry, Jerry. Jerry. So Jerry had $100. And compared to Jeremy, all of us here have more than $100, except for me. I broke. And so, all of you rich folks out there, I know you'll have more than $100 than Jeremy, so Jeremy is the broke one. At any rate, Jerry had $100. He went to a computer store, a bookstore, and a music store. He spent 3 times as much money in the computer store as he did at the music store. He spent 12 less at the bookstore than at the music store. He then had $37 left. Using X to represent the amount he spent at the music store, express in terms of X. Again, using X to represent the amount he spent at the music store, express in terms of X. The following, I guess. Yes, Mom?
Wait, never mind.
Yeah. The following. The amount that he spent. Oh my goodness, sorry. You want to know the amount that he spent at the computer store. That's to be the first one. Then the amount he spent at the bookstore. Okay, so using X to represent the amount he spent at the music store, expressed in terms of X, the amount spent at the computer store. Okay, so he had $100, right? He went to the computer store, 3 stores: computer store, bookstore, music store. At the computer store, he spent 3 times. He spent 3 times as much money in the computer store as he did in the music store. Okay, if we use X to represent the amount of money spent at the music store, what is the amount of money spent at the computer store?
X times 3.
X times 3, or
3 times.
3x. Because remember, it says that he spent, when he went into the, so we went into the music store, he spent X amount of money. We don't know how much money he spent in the computers inside the music store, but he spent X amount of money in the music store. That's what they tell us. Now, when he went to the computer store, he spent 3 times as much money in the computer store as he did in the music store. So if he spent, this is something good for you. If he spent $3 in the music store, how much did he spend in the computer store?
3 times as much.
3 times as much, which will be what? If he spent $3 in the music store, so let's say that this is M. What's the other one?
So times it by 3.
Yeah. If he times it by 3, so if he spent $3 in the music store, how much did he spend in the computer store?
9.
Say it again. 9. If he spent $4 in the music store, how much did he spend in the computer store?
12. Wait,
12.
12.
If he spent $5 in the music store, how much did he spend in the computer store?
20.
No.
Wait.
15. Very good, because 3 times as much. If he spent $6 in the music store, how much did he spend in the computer store? 18. And finally, if he spent $7 in the music store, how much did he spend in the computer store?
21.
21. Very good. And so that means that the amount that he spent in the computer store is going to be X times what?
3.
Times 3, which is what?
9.
3x.
3x.
Oh.
Okay. X times 3 is 3x. Okay, so that's how we do it. So that's for 1 point. So again, the amount that he spent in the computer store is 3 times as much. 3 times as much money. So copy this question down, write it down for me, write down my solution, and then also send the picture to me. For those people who I have not seen anything from, any notes from, any pictures from, please do so. Especially if I'm not hearing your voice. Please send the notes to me. All right.
Done.
Done?
You can write that little note on the side.
Say it again?
You can write that little note on the side too.
Yeah, you can write down the note on the side. Boy, Dior. Very good. Very good. Thank you, Ashanet. Thank you, Sean. Thank you, Mikkel. All right, so all right, so Let's continue.
Hold on, just.
It's not just petite.
That's not.
Y times is 3x. I know it's e squared like 3 times y 3x.
Why 3x? Because, alright. You understand this part where we say if he had $3, if he was at the store and he paid $3 at the music store, it'll be $9 at the computer store. You understand this?
Yes, that's so.
Good. So the thing is, we don't know how much he spent at the computer store. Like at the music store, we don't know how much he spent. So they say, okay, since we don't know how much he spent, that would be X. So he could have spent $3, he could have spent $4, he could have spent $5, he could have spent $7. He could even spend $6, but we don't know how much he spent at the music store. We're saying if he spent $5 at the music store, then whatever that is, we got to multiply it by 3 to get 15. And if he spent $6 at the music store, then whatever we get for the music store, we have to multiply it by 3. So that's what this one is saying. This is saying whatever he spent at the music store, call it X. We need to multiply it by 3 to get what he spent at the computer store, which is 3x.
Okay, thank you.
That's what we're trying to say. So, I hope that explains. I hope that helps at least.
You go back on it.
Excuse me, Miss Petit. I'm not done.
Okay, you're not done. Oh, you're not done. That's Lionel?
Yes, ma'am. I mean, yes, sir.
Lionel, you're turning me into a lady now? International Women's Day was when? That was what? Yesterday or?
Yesterday.
Yesterday.
So Miss Petit is a lady now.
I know, right? No problem, Lion. We all make mistakes. That's fine.
I guess I start calling you Miss Petit then.
Oh, Ashley, don't rub it in.
Destiny.
She rub it. Come on, Ashley. Alright.
Let's see what the next question was.
The bookstore. Alright, so thank you, Ashnet. Thank you, Cooper. Thank you, Conrad. Let's move on to the next question. Alright, so this is algebraic word problems. So
Excuse me, Mr. PT. Can you go back on it? I want to write down the last part, but I'll screenshot that.
sure, no problem.
Thank you. You go carry on.
Wow, you screenshot that so fast. Like you screenshot that so quick. I was like, wow, y'all tech savvy. Really. You play games, they line up.
Oh, no. Oh, my mic is on.
Oh.
My bad.
Yeah.
No, I don't really play games.
Okay. Alright. I say that because you seem tech savvy. Alright. And we're off. So now we need to figure out the amount that he spent at the bookstore. So what did they tell us about the amount that he spent at the bookstore? He spent what? $12 less at the bookstore than at the music store. So okay, so let's do this. So if this is the music store and if this is the bookstore, let's say he spent $4 at the music store. How much did he spend at the bookstore? Well, no, that's not gonna be a fail. Let's use 14.
How?
Let's use 14. Let's use 14.
2.
Alright, so it's gonna be, you're gonna minus what? 12.
Well,
Because it's $12 less. So it's gonna be what? 2. Let's say that he spent $15 at the music store, right? How much did he spend at the bookstore?
3.
3. Very good. Because you say 15 minus 12, which is 3. If he spent $16 at the music store, how much did he spend at the bookstore?
4.
4. And finally, if he spent $17 at the music store, how much did he spend at the bookstore?
5.
5. Very good. Alright, so that means that if we're trying to represent it in terms of a formula, how would we write it? Remember, X is the amount to represent how much he spent.
12 times 12 minus X.
Say it again.
Minus 12.
Say it again. Say it again.
12 minus X.
Is it 12 minus X? Look at it. These values. It's 14
Can I
minus
ask
12.
something before I answered?
Go ahead. Go ahead, Nancy.
12 times X.
Why would you multiply?
12.
I said 12. Oh, minus X. Sorry.
No. Notice this is the
I
amount
was, I was saying 3X minus 12.
No, they say it can't be 3x minus 12 because they say that he spent $12 less. Oh. At the bookstore. Yeah.
X minus
$12 less. Oh. Yeah, because that's true. That's true, Nancy. Because it says he spent $12 less at the bookstore. No, we're trying to find the bookstore now. Than at the music store. Yeah, we right.
The music store is 3X. Yes.
No, the bookstore is not 3x. The bookstore.
The music store.
The music store is how much?
3X, eh?
No, the music store. The computer store is 3x.
Oh, the music store is X, so it'll be X minus 12.
Yeah, it's gonna be X minus 12.
What?
What do you mean what?
I said that.
No, you all say 12 minus X. Big difference.
Oh, I just saying.
Someone did say that.
Someone say X minus 12?
Yeah.
Yes. Yeah.
I know X minus 12.
I did. Did I switched it?
I heard somebody say X minus 12.
But anyway, if you said X minus 12, you're correct. Because it's clear. X minus 12. X minus 12. X minus 12.
As long as I taught the computer, wow.
The amount that he spent at the music store minus 12. That's what they say. It says that he spent $12 less at the bookstore than at the music store. So whatever he spent at the music store is going to be $12 less. He spent $12 less at the bookstore than at the music store. So clearly he spent more money at the music store, which is $12 more. At the bookstore, he spent $12 less than at the music store. So it's gonna be whatever he spent at the music store minus 12. And so that's what this X means. Whatever he spent at the music store minus 12. And so we have it. We're almost done. We know how much he spent at the computer store. That's 3x. We know how much he spent at the bookstore. That is whatever he spent at the music store minus 12. So it's x minus 12. And so let us continue. Wait a minute. Hello, can you also hear me? Figured. All right. Sorry about that. Can you let me now?
Teacher will.
Whoa.
Can you hear me now? Someone already tried to take over my class already? I didn't even go on 2 seconds. Are we good? Can you hear me?
Mr. Petit.
Yes, ma'am.
Hello?
Yes, can you hear me?
Hello?
Hello?
You can ask?
I can hear you.
Hear me?
Where you going?
Can you hear me?
Yes, sir.
Yes, sir.
All right. I was saying, someone already tried to take over my class when I left.
Yes, Lionel.
Lionel.
No, sir.
I thought someone wanted to be a teacher, so I let that in.
Yeah.
Lionel wanted to be a teacher.
Lionel wanted to be a teacher already? I didn't even go on 3 seconds. Wow. All right. Okay, so let's begin. Let's continue. Okay, so I'm gonna allow you to do, which is this one. This is the next part of the question. The next part of the question is B. So form an equation in terms of X for the total amount spent, and then solve it. I'll be right back. Come right back.
What you say, Mr. Petit?
Again?
What they said to do?
Form an equation in terms of X for the total amount of money spent.
Yeah, something like that.
Okay, so form an equation in terms of X, the total amount spent, and then solve the equation in B to determine the amount of music, the amount spent at the music store. So we have to form the equation. That's the first thing. Using all the information that we know so far. So we know that he spent some money at the music store. So we're gonna say music store. We know for sure he spent some money at the music store. And we know that he spent some money at the computer store, didn't he?
The next question is calculate the equation, right?
Yeah, solve it, yeah. And we know that he spent some money at the bookstore. Now, according to the question, they tell us that he then had $37 left. Okay, so that means, but he had initially $100 left. I mean, initially. So that means that if we take 100, right, and we minus it by the amount that he spent at the music store, at the computer store, at the bookstore, we should be left with how much?
37.
37. Okay. Again, if we take 100 and we minus it from what he spent at the music store, the computer store, and the bookstore, we should get 37. Now, how much did he spend at the music store? What did it tell us?
3x.
Music store.
X.
X. That's just X. At the computer store, how much did he spend?
3x.
3x. And at the bookstore, how much did he spend?
X minus 12.
X minus 12. And all that equals to
37.
37. And so we're going to gather all our x's together. So we have negative x, we have 3x, and we have x again. So we have negative x plus 3x plus x. And we want to gather all our numbers together. So we have 100. And we have negative 12. And all that should equal to 37. So what is negative x plus 3 plus 1? That's the same thing as me asking negative 1 plus 3 plus 1. That equals to what?
Pardon? I know what you're saying.
Negative 1 plus 3 plus 1 is what?
That'll be 5x.
4x.
No,
You said 1.
negative 1 plus 3 plus 1.
It's 4x, eh?
No, mom.
Okay.
5x.
No.
3x.
This is a negative 3. Okay. You owe $1, right? You pay back $1.
3x.
Listen carefully. You owe $1. You pay back $1.
It's 3x.
So
it only could be 3x.
So it's 3x, yeah. So these two cancel. So you're just left with 3. Okay, again, let me explain again. So you have a negative 1 plus 3 plus 1, right? This is going to be equal to, there's different ways we could look at it. We could say negative 1. What is 3 plus 1? 3 plus 1 is what? 4, right?
Oh.
And we could write negative 1 plus 4 as 4 minus 1. And that's just 3. There's different ways to do it, but the answer is 3. So negative 1, 3, and 1 is simply 3x. So it's 3x plus, what is 100 minus 12?
80.
80.
I mean 88.
88?
Oh, 88. Sorry.
Oh, I
88
thought I was wrong.
equals to, very good, 37. And then what do we do? This
Carry the 8 to the 37.
very good. Carry the 88 to the 37. It's going to be equal to 3x is equal to 37 minus 88. And this is going to be equal to 3x. What is 37 minus 88?
Negative 51.
That doesn't make no sense. Why are we getting a negative number?
Yeah, negative 51.
No, shouldn't we get a negative number? Oh, I see our problem. Oh my goodness, I see our problem.
Are we supposed to include the 100?
I see the problem. One moment. Sorry. Made a big boo-boo. The problem is, we forgot that, or I forgot really, that this thing was in the bracket. And so when you're in the bracket like so, right, we have to respect that. And so I'm sorry, this is supposed to be in the bracket. And so what happens here is we have to, there's different ways we could do it. What I would do is I would add everything in the bracket first, and then what we have to do is we have to multiply -1 or the negative by what we have in the bracket. And so that's the problem. So there's gonna be 100 minus open bracket. Remember, we still have the x plus 3x, but this time we don't consider negative x. We just leave it as x itself. So plus x, and then minus 12 equals 37. And so we have 100 minus open bracket. What is x? 3x and x. That's what? 5x minus 12. It's going to be equal to 37. Now, what we do here is we multiply the -1 by the 5x. So negative times 5x is going to be -5x. And negative times the -12 is going to be what? What is a negative? Yeah, a negative times a negative is a positive. And it's going to be equal to 37. And so we have 100 here. Now we could group the like terms. What is 100? So we're going to add 112. So what is 112?
112.
Good. So we have a -5x plus 112, because we add the 100 and the 12. That's going to give us 37. Then we send the 112 over. It's going to be equal to -5x. It was a positive 112, but when we send it over, it becomes what? Negative 112. Now, what is 37 minus 112? What is 37 minus 112? 37 minus 112, people.
-75.
-75. Now divide. Now what we do at this point?
Divided by both sides.
Divide what by both sides?
-5.
5 or -5?
-5.
My bad.
5, no problem. -5. And so the -5 and -5 will cancel out. So we are left with x is equal to, what is -75 divided by -5?
15.
15. Positive 15, because the negative and a negative cancel each other, so it's going to be 15. And so x is 15. So what is the amount of money that was spent at the music store?
What's the question?
5?
Say it again. What is the amount of money spent at the music store?
15.
15. Yes. Where's Dior?
Yeah, I was eating dinner.
No problem. I would have never thought to do it like that. You minus 100 from the break. It's pretty good. We still end up getting 15, which is good. Very good. All right. All right. Let me know when we finish. Any questions on this, please? Let me know.
So when you send a 100 over, you only added the 12, right?
When I send 100 over. What 100? I didn't send 100 over, you know. I add the 100 and the 12 first before I send the 112 over.
That's what I mean. I saying you send the 100 over, then added the 12.
I understand. What I did, I took 100 and I added the 12.
All right.
Then, once I took the 100 and added the 12, then I sent the whole 112 over. You understand? Or no? Hey, Ricardo, you understand?
Yeah, I get it.
Okay. Any other questions from anyone? Alright, if you don't let me know, I wouldn't know if you don't understand.
I understand.
Okay, that's good.
Can
Alright.
you recap it overall, please? Summarize.
Summarize, okay. Summary, no problem. So, remember that Jerry had $100. Okay? That's what he had in his pocket. Then he went to the music store. Then he went and spent some money. Then he went to the computer store and spent some money. Then he went to the bookstore and spent some money. Then after he spent money from all these places, he's left with $37. Now we don't know how much money he spent at the music store, so we say, okay, let's call that X. But we do know that whatever he spent at the music store, it was 3 times as much. It was 3 times as much that he spent. Whatever he spent at the music store, whatever he spent at the computer store was 3 times more than what he spent at the music store. Again, whatever he spent at the computer store was 3 times more than what he spent at the music store. And then whatever he spent at the bookstore was $12 less than what he spent at the music store. And so what we did was we had to bracket this out because we had to first deal with this thing in brackets. We first had to figure out we basically had to add up what he spent at the music store, computer store, and bookstore. Once we finish add that up, then we say, okay, like terms, x plus 3x and x, that's gonna be what? 5x, right? X plus 3x and x. Then we only have the negative 12 at the back, and there's no like terms with negative 12, at least not inside this bracket. Then we get 5x minus 12, but we know we have a negative out front, and so we have to distribute that negative to each term. So we get negative 1 times 5 is negative 5x, sorry. Negative 1 times 5x is negative 5x. And a negative is a positive, leaving us with positive 12. Then after that, we add 100 and the 12, giving us 112, and that equals 37. We send the 112 over, so we're left with 37 minus 112. And then we just have to solve this equation naturally. 37 minus 112 is negative 75. And negative 5x, what we have to do is we have to divide both sides by negative 5 to get rid of the negative 5 on this side. And again, divide by negative 5. So negative 75 divided by negative 5 is going to be positive 15 because the negative and the negative cancel out each other. Okay? And so we get...
Thank you.
No problem. So we get 15. And that's a mouthful, but that's how it'll be sometimes. Alright. 2016. Yeah, sorry for those kids who was in 2016. They had something. Okay, and how much they give them for that question? 2 points. Wow. Interesting. Alright. Okay, so let's go back to... Wow, I don't understand how it's 7:56. Wow, I mean, we did start late, so that's true. We did start late. Alright, so let's go and wrap this one up. The last question on this 2017 paper, we finished it. This paper too. Oh my goodness. Oh my. Add. If any of y'all get this wrong, man, it's like easy 2 points. Alright, so add it for me. We're gonna add it by hand. Okay. So no calculators, Nancy.
She probably don't use it.
No, the card.
Tomorrow is
No confidence.
I never add. I said you mean to the bus like that.
I know, right? She just
This clarity is
she didn't even give you the benefit of the doubt. She just threw you in the bus. Let's add by hand.
Me, I'm let her slide. She don't know me.
Okay. Let's go. So let's add it by hand. Nobody use calculators.
Finally, some justice. Yes.
Alright.
I get 19,735.
You get what?
19,835.
Say it again?
She get 19,035.
I don't know. For some reason, guys.
19,835.
Okay.
I get that too.
Okay, I hope that's right.
I got you too.
I get 19.
Then you know, that is like what?
Okay, so
I got 19,835.
okay. So the first thing we're gonna do is we're gonna add this thing. So 4 plus 4 is
8,
7.
15.
15.
So we put the 5 down and bring the 1 up. 8 plus 2 is
10.
10 plus 3
12.
plus 3.
Wow.
13.
14.
Put the 3 down, put the 1 up. 5 plus 3,
8.
8.
8.
Alright, so this is gonna be 19,835. Did anyone get that wrong?
No, sir.
Alright, that's good. If you get that wrong, boy, I don't know what to say. I don't know what to say. Okay, 5, 8, 4. So 19,835. So we want to end on a good note, eh? With a nice, easy question. And so the next time we come, which is tomorrow, God's spell, we have to finish up. We have to do number 5 for this question. Hopefully we get to see number 4. And then we have to go to Lionel's 2016 paper. Lionel, we wanted to do the 2016 paper, but you left that day.
I wasn't on call.
Say it again?
I was on call, but wasn't talking.
You was on call? Oh.
Yes, sir.
Because I asked, I said, I thought you I thought that you was there, but I thought you was there, but not there. Like I saw you there, but
I was there.
oh,
Call
like
it.
I even asked. I called you. I was like, Lionel, we gonna do your paper?
Oh, I wasn't responding. What?
No, no. I was like, Lionel, we gonna do your paper now. He's like, okay. I didn't hear nothing. I say, okay, well let's just go back to normal. We were to do your paper before your test. How was the quiz anyway?
It wasn't that bad, but I hate story problems though.
Oh, okay. Alright, so we need to fix that. We need to go over that paper. We're gonna do it tomorrow. We're gonna do it tomorrow, but you could have got a good advantage had you responded. But anyway, let's do it tomorrow. We're gonna deal with that 2016 paper. And so we'll be on two 2016 papers. Alright, so okay, so let's my favorite part of class, English. Now, the moment of truth. Okay, by the way, for those persons who are not doing my language Bgcse or Bgcse, you're free to leave. Make sure send class notes for math. Yeah, so now yes, ma'am.
Yesterday, when I left to see the news talk, and I know what you say, and I'm like to see what you did yesterday.
Say it again.
Science. My mom, I tell you my stuff is free go and it's cut off and on.
Yeah.
When you was talking to me, it cut off and I kept on off.
Oh, okay. Well, that's what happened. Okay. All right. So let's go into language. Can't wait. Did anyone? Oh boy, moment of truth. Did I give y'all any homework for this?
No, sir.
Okay, good. I guess I got tired of giving homework. I'm like, you know what? They don't do it. But Miss Cooper, I'm glad you did do the science homework for a change. Right, Miss Cooper? Miss Cooper did yours too? Oh, she had to leave. I know she ain't wanting not to talk.
Listen, I can use the bathroom.
Oh my goodness. Too much details. Alright, anyway. See you in a few. Okay, so yeah, so we're gonna deal with this passage today. And as we go through the passage, if you find some words that you are not familiar with, then don't wait on me to tell you. Right? Try find the definition of them, and try use them in a sentence. Try to figure out how you can use them in your own writing. Words that you don't know.
Are you saying, Mr. Betty? No.
Oh, saying it's a good thing that you did your science.
Of course, I always do.
Yeah. All right.
I had to do that one yesterday because I do not know why.
Yes. So I guess I ain't
felt guilty.
She felt guilty, yeah. Conscience.
No, I can do them. I serious.
You said that last time.
I did do it, right?
Okay then. All right. Questions 22 to 31 are based on the following passage and supplementary material. Okay, so this passage is adapted from Brian Walsh, The Whole Food Blues. Why organic culture may not be so sustainable. Copyright 2012 by Time Inc. What do you think this essay is going to be about using this title? So what does the title tell us about the essay, even before we read it?
Well, let's say why organic agriculture may not
be suitable, sustainable.
Sustainable. What do we mean by sustainable? Sustainable.
Mhm.
Sustainable. Say it again.
It can't be maintained or something like that.
Maintain. I like that word, maintain. So, give me another word for sustainable. Other than maintain. Maintain is a good one. You're also quiet. Sustainable. Go ahead. Hello.
Like I say, we support it.
Supported. Close. Not really though. When we say sustainable, we mean like if something is sustainable, then that means
Approved.
say it again.
Reliable.
Approved.
Approved. Not so much approved. I like that word reliable.
Reliable.
Say it again.
No, I was saying reliable again.
I like the word reliable. That's close. But if something is sustainable, that means that
Affordable.
we could not affordable.
But depend on
Certain.
Yeah.
Able to meet
Supportable.
for a certain rate.
Like we could depend on it for a long continuing of time. Like it's not gonna break down on us, right? Like it's going to like if something's sustainable, that means that we're able to sustain it without giving way, right? And so um we're able to maintain it, we're able to keep it going um reasonably without it affecting us too bad. So if something is unsustainable, that means that we can't sustain it. We cannot continue this process. So they're saying why organic agriculture. When we say agriculture, what are we talking about? Another word for agriculture. Start with that.
Farming.
Farming, right? So why organic farming may not be so sustainable. That's what he's trying to. That's the case that he's trying to make. And they say whole food blues. What do you think he mean by whole food? Why say he? It's just felt like a male. Anyway, whole food blues. When he say whole food blues, what you think he talking about? Whole food blues.
Sadness.
Sadness, right? Whole food blues. In other words, this is gonna for those people who like whole food, like myself, we're gonna get the blues. We're gonna get the sadness when we read this article. You know? Whole
Does it seem like whole food?
Yeah, whole food. Like whole food refers to
Veggies, fruits.
Yeah, veggies, fruits,
Nuts.
you know, nuts and stuff like that. Stuff that are not processed, but come directly from plants.
Say like vegetables, but I don't like all of them.
Like potatoes, cauliflower, you know, spinach, broccoli, you know, whole food. Anyway, so let's read it. It says, see how long this thing is though. Oh, even it isn't as a diagram. Okay. So I don't even know if we're gonna end up doing these questions because we have to explain this paragraph, this essay, but
I just want to ask if you could explain because it's helped me understand.
say it again.
I said I just about to ask you if you could explain it because it's helped me understand it more.
Yeah, we can explain it first. And we can see where that carry us. That might carry us at the end of time, but we'll see. We might could get in some questions. I don't think we're gonna finish the whole
Show your time, my friend, though.
Say it again.
Show your time, right?
Yeah, my time is right. You know that we spring forward in the spring.
Saturday.
Yeah. And we fall back in fall.
Yep.
Sorry, my friend. Okay, anyway, so let's go. It says, when it comes to energy, everyone loves efficiency. Cutting energy waste is one of those goals that both sides of the political divide can agree on, even if they diverge on how best to get there. Energy efficiency allows us to get more out of our given resources, which is good for the economy and mostly good for the environment as well. In an increasingly hot and crowded world, the only sustainable way to live is to get more out of less. Every environmentalist would agree. But change the conversation to food, and suddenly efficiency doesn't look so good. Conventional industrial agriculture has become incredibly efficient on simple land to food basis, thanks to fertilizers, mechanization, and irrigation. Thanks to fertilizers, mechanization, and irrigation, each American farmer feeds over 155 people worldwide. Conventional farming gets more and more crop per square foot of cultivated land, over 170 bushels of corn per acre in Iowa, for example, which can mean less territory needs to be converted from wilderness to farmland. And since a third of the planet is already used for agriculture, destroying forest trees and other wild habitats along the way, anything that could help us produce more food on less land would seem to be good for the environment. Of course, that's not how most environmentalists regard their arugula, a leafy green. They have embraced organic food as better for the environment and healthier and tastier too than the stuff produced by agricultural corporations. Environmentalists disdain the enormous amounts of energy needed and waste created by conventional farming, while organic practices, foregoing artificial fertilizers and chemical pesticides, are considered far more sustainable. Sales for organic food rose 7.7% in 2010, up to 26.7 billion. And people are making those purchases for their consciences as much as their taste buds. Yet, a new meta-analysis in Nature does the math and comes to a hard conclusion. Organic farming yields 25% fewer crops on average than conventional agriculture. More land is therefore needed to produce fewer crops, and that means organic farming may not be as good for the planet as we think. In the Nature analysis, scientists from McGill University in Montreal and the University of Minnesota performed an analysis of 66 studies comparing conventional and organic methods across 34 different crop species, from fruits to grains to legumes. They found that organic farming delivered a lower yield for every crop type, though the disparity varied widely. For rain-watered legume crops like beans or perennial crops like fruit trees, organic trailed conventional agriculture by just 5%. Yet, for major cereal crops like corn or wheat, as well as most vegetables, all which provide the bulk of the world's calories, conventional agriculture outperformed organics by more than 25%. The main difference is nitrogen, the chemical key to plant growth. Conventional agriculture makes use of 171 million metric tons of synthetic fertilizer each year, and all that nitrogen enables much faster plant growth than the slower release of nitrogen from the compost or the cover crops used in organic farming. Now, when we talk about a green revolution, we really mean a nitrogen revolution, along with a lot of water. But not all the nitrogen used in conventional fertilizers ends up in crops. Much of it ends up running off the soil and into the oceans, creating vast polluted dead zones. We're already putting more nitrogen into the soil than the planet can stand over the long term. and conventional agriculture also depends heavily on chemical pesticides, which can have unintended side effects. What that means is that while conventional agriculture is more efficient, sometimes much more efficient than organic farming, there are trade-offs with each. So an ideal global agriculture system, in the views of the study's authors, may borrow the best from both systems, as Jonathan Foley of the University of Minnesota explained. The bottom line, today's organic practices are probably best deployed in fruit and vegetable farms, where growing nutrition, not just bulk calories, is the primary goal. But for delivering sheer calories, especially in our staple crops of wheat, rice, maize, soybeans, and so on, conventional farms have the advantage right now. Looking forward, I think we need to deploy different kinds of practices, especially new mixed approaches that take the best of organic farming and conventional farming systems, where they are best suited, geographically, economically, socially, etc. And so here we have a figure, it's figure 1, and this is organic yield as percentage of conventional yield by crop. And this dot is all crops, 316 crop type, this box shows the crop type. Fruits, represented by this circle. Oil seeds, crops, 28. Cereals, 161, and vegetables. At 100%, the organic yield is the same as the conventional yield. The number of observations for each crop type is shown in parentheses. Organic yield as a percentage of conventional yield by species. At 100%, the organic yield is the same as the conventional yield. The number of observations for each species is shown in parentheses. Figures are adapted from Farina, Surfet, Navin, Rahman, Cuddy, and Jonathan A. Foley, comparing the yields of organic and conventional agriculture. Copyright 2012 by Nature Publishing Group. Okay, so can someone summarize or tell me the main point? I want the main point of the article. The main point, the main idea.
He's saying that organic foods are way better than conventional foods, and he was making a comparison, a compare and contrast to it.
The first part of your answer is not correct, but the second part is. I'm talking about the main idea, like the main point.
How they were taken at the beginning. Okay, based off my understanding, it made it seem like they're starting to do less of the organic stuff and started to do more of the conventional stuff, whereas because the rate of they could get more for less.
Yes.
When it comes to doing it the opposite of organic, basically looking at the numbers and the calories rather than the quality itself.
Yeah. Very good answer. Anyone else? What is the main idea of the passage?
I can't summarize this one.
Say it again, Cooper.
I can't summarize this one.
You can't summarize this one? Why? Do you understand it? Or you need me to explain it?
Some parts I can.
Some parts, okay. Alright. So the main idea of this passage, right? The title summarizes it all. Why organic?
I think the main idea is about how they say organic culture can make people people like
I could barely hear you. Go ahead.
live their best way from the others. like it.
Your audio is not good. Maybe you could try logging out and coming back on, because I can't really hear your statement. Hastily.
But you there? If you don't hear it.
It's not clear. Like, I can hear you, but it's muffled. Hello, can you all hear me?
Yes, sir.
Honestly, yes, sir.
Yeah, her audio is. We can hear you, but it's muffled. So, like I said, try logging out and coming back in. So the main idea of this passage is that although a lot of people like easy started. Okay, let me just state the main idea and then we can explain it in more detail. The main idea is basically that although organic foods are better than the foods done with fertilizers. Yes, ma'am?
You hear what I said? Because I was talking and I hear you.
Okay, good. I hear you much better now. Go ahead.
I was saying I think the big thing is about how they like what how organic agriculture is like better for us to live. But like if you don't like it or whatever, it's your own.
No, that's not the main idea. No.
No, okay, I just say it.
No problem. But the main idea is basically that, hey, when we use conventional farming, when we say conventional farming, that's with fertilizers, that's with, synthetic stuff, artificial stuff. When we grow the plants like that using the artificial stuff, the fertilizers and everything, we get more plants, we get more crops produced as compared to when we do it, or when we just plant the plants and just let them grow naturally. All right. And so what he's trying to say is that, hey, it's actually better for the planet if we use the fertilizers and if we use the artificial things for the plants, because so the idea is the following: like if we have a plot of land, right? If we have a area, right? So let's say this is the same area. So let's say that this is a rectangular plot of land, and we plot these plants. So we plot these plants. Let's say that let's use a grain for the plant. So let's say we plant these plants, right? So this is the first plant, the second plant, and so on, right? And we're trying to get crops from these plants that we plant, right? And so this first plot of land that we did, let's say that this is Nancy's plot of land, and she's the farmer that she's gonna be using the fertilizers, because Nancy don't care. Nancy say, you know what, whatever works, let's get the fertilizers in, so we get these things, so we get these plants growing fast. So she's gonna do it the conventional way, right? But Mr. Petito, on the other hand, because he is, vegan and vegetarian, he say, you know what, I don't want to use no fertilizer. I just want to do it the natural way. And so I'm not gonna use no fertilizer. I'm just gonna do it the natural way, using the compost, using animal manure, whatever, just whatever it is, just not the fertilizers.
But you spelled the fertilizer wrong.
I spelled it wrong. My bad. Yeah, you're right. But you get what I'm saying.
You put fertilizer.
I put fertilizer. Yeah. Thank you. That's a good catch. So what they're saying is that after the time period comes, and you look at Nancy's crops versus my crops, Nancy's gonna have way more crops right? A crop's gonna be running over than me, right? And so in me, I'm gonna get a little bit because I doing it the natural way. I'm gonna get a little bit. And so the man is saying, hey, we don't have a lot of land on planet Earth. We only have a certain amount of land. Like, and so if we find a way that we could produce more crops and feed more people, with a smaller piece, with the same land, we get more crops based on the same land. He's saying, hey, that this is more efficient, right? This is more efficient for the environment. It's more efficient. It's more better for the environment because hey, we getting more for less. All right, compared to if we do everything the natural way, well, or the organic way, well, we don't use no fertilizers, but we don't get much produce. And he's saying that you don't want to do it like that because hey, using the same plot of land, but it's almost like you wasting the land because you don't have all them being produced like how you up there. And so that's the idea. Now, so that's the idea. So he is saying that fertilizers, doing it the conventional way, is better for the earth. Doing it the conventional way is more sustainable. That's the word, right? It's more sustainable. But he also note that hey, even though you basically you get more for less. You get with using the same amount of land, you get more. That's his reasoning. But I like that how he balanced it out at the end. Coming down to the end, he started talking about the negative impacts of using the fertilizers. Anyone can remember what are some negative impacts he talked about using the fertilizers? Like what could they cause in the long run? Even though they give you more plants for the same amount of land that you use.
May have chemicals in it.
They can have chemicals, and where the chemicals are gonna go?
On the plants.
In the water.
In the water.
In the water.
But not all nitrogen. Sorry, but not all the nitrogen used in what from conventional fertilizers ends up in the crops. Much of it ends up where? Running off
into the ocean.
Into the what? Oceans. Creating what? Vast polluted.
Dead zone.
Dead zone.
Yeah, it's called from the rain.
So he is saying that yeah, even though we are able to get more plants with the same amount of land as compared to the organic thing, the conventional way, the way with the fertilizers, is not all that good. We still having a lot of pollution. Okay, and so he ended off by trying to say that hey, we need to have a balance, because he's saying that hey, okay, the organic way is not all that good. Why is the organic way is not all that good according to this article?
Low. You don't get. It does take long till I get back.
Like you said, low yield, right?
Yeah.
For the amount of land that we spend, we get a low yield, right? We don't get as much. But what's the advantage of using the organic?
The crops.
What's the advantage?
It's healthier.
Get more.
And it's I think it's healthier and it's
healthier.
And it's environmentally friendly. Like it's friendly to the environment.
And you don't get the runoffs from you don't get the pollution, right? The negative side of the good side. What's the good side of using the fertilizers? The good side.
You get more for less.
Yeah, you get more for less. You get more crops for the same amount of land that you bargained for, that you got. So even though Nancy, let's go back. Oh, I moved it. Even though Nancy in her garden, she got her crops, way more crops than mine. The fact is that Nancy also contributed to the pollution. All right, and so causing the earth to be more and more polluted. And so what he's saying is that, hey, all right, we're gonna have a lot of side effects. We're gonna have a lot of these things if we use the conventional way, if we use the fertilizers, if we use pesticides. So what we could do is we could have a balance. That's what he said. You only use the organic farming for a certain type of crops, and you only use the 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 fertilizer ones for a certain type of crops. And so trying to find that balance is what he's saying. All right, so that's basically what this essay is about. All right. Okay. Did you all know this? Like, did this information come across as new to you?
No.
Say it again.
I'm familiar with it.
Familiar with it?
Yeah.
Okay. All right. So that's what the essay was about. So let's read this. Let's take a look and explaining these diagrams now. So what is this trying to say? Figure 1. Right. So if we look at it, say organic yield again by species. Okay, so this is by crop type. So this is organic. How much the organic yield, right, as a percentage of conventional yield by crop type. So this circle, this dark one, is referring to all the crops, and all the crops in total was 316 crops. And if we go down a bit, all the way here, we find that this is going to be, say, this was 70. So about 70. If this is 70 in the middle, we call this 70. It's supposed to be like 72, 73, thereabout. Alright, so let's say it's 73%. So, and then for this one is going to be like 65, 66 thereabout. This is the oilseed crops. Cereals, they're close to 70 as well. And then for this one, it's fruits. Fruits is very close to 100, that's about 98. So at 100%, the organic yield the same as the conventional yield. Okay, all right. Okay, so this is very important for us to understand. What they're trying to say is that when we see that it reached 100%, that means the organic yield is yield the same thing as the conventional yield. Okay, so let's take a look at our vegetables, right? So our vegetables, this is going to be, let's say this is say 65, look like 65%, right? Now 65%. So what they're trying to say is that because of 65%, you notice how far that is away from 100. So what they're trying to say is that if this, say, let's say for example, this circle was here, then we could say that for vegetables, the organic and the conventional yield the same amount, right? If this circle was here at 100. But this circle is not here at 100, at 65, which means that the organic crops or the organic farming did not yield as much as the conventional. In fact, it was far off from the conventional. Okay, the same thing is true for this one, and for this one. This one is 73. Notice how far away that is for from the conventional. The conventional, we know that the conventional and the organic yield the same thing if this dot was right there. So they're saying that for all crops, for all the crops combined, the conventional yield was way bigger. Like they had more. Like, but if this dot was say here, then we could say, hey, there's no difference. They yield the same thing. But since this dot is at 73% and not 100%, that means that the conventional yield, say, what is 100 minus 23? Sorry, 100 minus 73. What is that? That's 27%. So this is saying that the conventional people yield 27% more than the organic. Right? So they yield 27% more. If they were together, if the 73, if this dot was right here, you would say that they yield the same thing. Now for this one, for the fruits, we see that there's not much of a difference though. You see that, right? Like this is 99, this is 99%. And for the crop, for the conventional, it had 100. So that means that there's but a 1% gap. So that means that the organic, when it comes to the fruits, the organic and the conventional don't really have much of a difference. Okay, that means that they yield basically the same amount. So that's why they say, hey, let's use organic farming for fruits. Because, well, for fruits, the organic farming and the conventional yield the same thing, just about. And so if they yield the same thing just about, and we know that organic is better than conventional when it comes to pollution, they're saying, hey, let's use organic for the fruits. But we can't use organic for stuff like the vegetables because, man, that's too much, that's too far. Like the organic one, what is 100 minus 65? That's 35% more. So we had like a 35% more yield for the vegetables, for the conventional vegetables, the one that they use for fertilizers, as compared to the organic. Like there's 35% more artificial crops that we got compared to the organic ones. So we can't use organic for vegetables. It wouldn't also be wise to use organic for the cereals because it's still too far away. Okay, it's still too far away from the conventional. Do y'all understand the diagram? I hope I explained it properly. I don't know if I explained it. Let me understand. Y'all understand the diagram?
You could do it one more time. I started with the whole thing.
Yeah, you could do it one more time. I get lost.
You got lost. Okay. Okay, so the idea is the following, right? Like, we're trying to compare how much more conventional farming yields as compared to organic farming. So what we're trying to say is that if we look at this 100, right? The closer these dots is to 100, that means that organic farming, right, and conventional farming had the same amount. So if we look at fruits is very close to the 100. That means that organic farming, when you do fruits with organic farming, when you do fruits with conventional farming, like there isn't much a difference. They produce almost the same amount, right? Now, the further away you get from that line, right, the greater the yield for the conventional versus the organic. So if we look at oilseed crops, they don't produce on organic farming. They don't produce as much as the conventional because we see that there's a distance, right? So for this one, it's about 80 something. In order for them to produce the same amount, both of them have to be at 100, right? And clearly there's a distance. It gets even worse when you talk about all the crops. This is about 35% difference. It gets even worse when we're talking about cereals, right? And it gets even worse when we're talking about vegetables, which means that when it comes to organic farming and conventional farming, organic farming for vegetables is way worse than conventional farming. In other words, you get way less vegetables when you do it with organic farming as compared to when you do it with conventional farming. That's what this gap is indicating. Now, like I was saying, if this circle was right here, that would mean that when we do our vegetables, we get the same amount whether we do it conventionally or organically. All right. Does that helps to clear it up?
You say if what circle was there?
Like if this circle was right here, that would mean that the same amount of when we plant the vegetables, the same amount of vegetables we get for the organic is the same amount of vegetables that we get for the conventional. But that's not the case. This circle is far away, which indicates that we don't get the same amount of vegetables when we plant it organically as compared to when we plant it conventionally. In other words, they're saying that it's far less vegetables when you do it organically as compared to when you do it conventionally. You understand?
I think I get it.
And the same thing applies to the next diagram. So, based on this diagram, right? Let me ask the question. Which species of crops, right, is closest to yielding the same amount as conventional? Which group of crops, if we plant them organically, will be the closest to getting the same yield as the conventional? Which one would it be?
Pardon?
Again, which crop, when we plant it, would...
Say
it again?
Soybean.
Soybean. Because soybean is closer. Sorry, then all these to what? To the 100. You know what I'm saying? So this is saying that if we were to plant soybean organically, and if we were to plant soybean conventionally, and if we were to plant tomatoes and barley and maize conventionally and organically, the closest one to yielding the same amount as conventional, the closest organic crop to yielding the same amount as conventional crop would be soybean. Okay, it's still a great amount. This is about 85. It's 100, so about, say, 15% more, right? 15% more. So so that means that for the soybean, if you plant soybean conventionally and organically, the organically would not be as much as the conventional. It would be 15% less than the conventional. So in terms of how much you get, it gets even worse when we start talking about the corn, maize. It gets even worse when we start talking about tomato
and the wheat.
And by the time you get to the wheat, it's way better that you plant it conventionally, because there's 40% difference. Like you get 40% more wheat if you plant it conventionally as opposed to if you plant it organically. You only get you get way less. But if this diamond was here, what would that tell us? This diamond was on. Say it again.
That the organic is the same as the conventional yield.
Very good. That if we plant wheat organically and wheat conventionally, we get the same yield. That's if this diamond was on this line. Since this diamond is so far up, that's telling us, hey, you know, there was way more wheat, about 40% more wheat that we get when we planted conventionally as compared to when we planted without the fertilizers organically. All right? Does that help to explain the diagram?
Yes, I understand it now.
Okay. Okay, that's good. Anyone else?
So when none of them on 100?
None of them at 100. The closest is the fruits.
Fruits, yeah. And then exactly, that's like 98, right?
Like 90,
99.
99, but it's close though.
Yeah.
Okay. So let's consider the questions. We can see how much we could do tonight. So for the questions, please write down the question and write down the correct answer. Okay, so it's gonna be, so let's go. Number 22. As used in line 14, simple most nearly means, is it A, straightforward, B, modest, C, unadorned, or D, easy? Again, as used in line 14, simple most nearly means straightforward, modest, unadorned, or easy.
When I say line 14.
So let's go to line 14. Sure. So we could be able to distinguish which one was the correct answer for that one. It says conventional industrial agriculture has become incredibly efficient on a simple land to food basis. Conventional industrial agriculture has become incredibly efficient on a simple land to food basis. Is it straightforward, modest, unadorned, or easy?
D.
Think about it.
D.
Say it again. D.
C?
Say it again. So I said I heard someone say C. He said simple. So look at it. Like it says conventional industrial agriculture has become incredibly efficient on a simple. This is something that is not complicated. Something is what? It's not complicated, it's not complex, it's what?
Easy.
Easy.
D.
Straightforward. So straightforward. I know it's kind of close with these two. But the answer is straightforward.
Before I see the question, I was not straightforward. When can they say easy, I was like, it could be easy.
Yeah, I understand. Yeah. It could be easy. But easy don't, I mean, simple, when he said simple in this case, And it means straightforward. It mean like, listen, it ain't complicated. It's like something that when you look at it, it's like you say on a simple land to food basis, like it's something that's straightforward. Okay, so let's go. This is number. So this number. I'm gonna do 2 more, and then we're gonna depart. So we can leave the rest for later. According to the passage, a significant attribute of conventional agriculture is its ability to what? Produce a wide variety of fruits and vegetables, maximize the output of cultivated land, satisfy the dietary needs of the world's population, or lessen the necessity of nitrogen in plant growth.
A.
A?
A.
A? Someone said A. Anyone else?
Is it A?
All right, the correct answer is we gotta read it. Look carefully at. Let's look carefully at say. Look at line 40. Okay, let's look at line 40 and 42. That'll help us.
I think it's B.
Think it's what? Let's look at line 40 and 42. To really hit this one. This is what? Line what? What did I say? Line 40 to 42, right?
40 to 42.
Yeah. All right, so it says, yet a new meta-analysis in Nature does the math and comes to a hard conclusion. Organic farming yields 25% what? Fewer crops than conventional agriculture, which means that what? More land is therefore needed to produce fewer crops, and that means that organic farming, we don't need all that. But it's saying that organic farming yields what? 25% what? Fewer, right?
Fewer.
Right, fewer. So that means that conventional farming yields what?
More.
Yields more. So you have more output, right? So let's go back here. So you have maximum output of the what? The cultivated land.
Wow.
Right? You get more for what you bargained for.
That was disappointing.
Yeah. I mean, it never talks about producing a wide variety of fruits and vegetables. I mean, the only indication we get of that it would be certainly, of course, with the study, and the different fruits and stuff that they use. But it's a wide variety of fruits and vegetables. I mean, I guess we could go with that. That's close to. I ain't gonna lie. That's close to. It's either A or B, but B is more nearly correct because it's saying that we could get more out of the land, right?
I don't like these questions because they're too close.
They're close, eh? All right, next up is number 24. Which choice best reflects the perspective of the environmentalists? Line 27 on conventional agriculture. Is it that it produces inferior fruits and vegetables and is detrimental to the environment? Is it is energy efficient and reduces the need to convert wilderness to farmland? It's good for the environment only in the short run, or it depletes critical resources but protects wildlife habitats. So you have to go to line 27, right?
Yes, sir.
Yes, sir.
Line 27.
I didn't even see the answers because I was trying to write the question.
Okay, I'll go back to it. So it says, of course, that's not how environmentalists regard their arugula. They have embraced organic food as better for the planet and healthier and tastier too than the stuff produced by the agricultural corporations. So how do environmentalists view conventional stuff? What is he saying?
He's saying that
Go ahead.
organic food is better for the planet.
Mm-hmm. So what do they think about? Not only is it better for the planet, but what is
Healthier,
it's healthier and
Tastier.
tastier than what?
That's just produced by
agriculture.
Than the stuff produced by fertilizers, right?
Yes, sir.
Okay, good. So let's based on that, let's answer this one. Which choice best reflects the perspective of environmentalists? Do they believe that on conventional agriculture? So do they believe that conventional agriculture produces inferior fruits and vegetables and is detrimental to the environment? That is energy efficient and reduces the need to convert wilderness to farmland. It's good for the environment only in the short run, or it depletes critical resources but protects wildlife.
Hey.
C.
C? A? What you going with?
A.
Why you say A, Miss Cooper?
I think C.
I think an A or C because it's saying it's good for the environment.
Remember, they said that environmentalists believe that organic food are what? Healthier, tastier,
tasty.
right?
Inferior means bad.
So they're saying that, so if they believe that organic food is healthy and tastier, that means that they believe that organic food is better or superior than conventional agriculture. So that means that they believe that conventional agriculture is inferior to agriculture, the organic ones. And they also believe that it's bad for the environment. So the correct answer is A.
So I was right.
Yeah, he was right. Alright. It's because they believe that it produces inferior fruits. These conventional stuff using fertilizers, it's gonna be inferior to the organic ones. Okay, so it produces inferior fruits and vegetables. Alright. We can end right there. And so, with that being said, I want to say a good night to each and every one of you. See you tomorrow, Godspell. And send in the notes as well. Alright?
What can destroy her?
And so, take care.
Bye.
Good night.
Good night.
Destroy is recommendable.
Good night, Mr. Badee.
Good night.